The altered concentrations could mean some type of pathology, including cancer. For this reason, the discovery of cheap and non-invasive diagnostic strategy for the early detection of cancer is an urgent priority. C. elegans possess several chemosensory receptors, allowing it to detect about as many odorants as mammals, even though they possess a relatively small number of chemosensory neurons. And they have three specialized neurons to sense volatile molecules. Here the authors propose a worm-based strategy to discriminate between healthy and breast cancer urine samples by exploiting the high sense of smell of the nematode. First of all, they examined the nematode's attraction to urine samples from cancer patients and healthy ones through a chemotaxis assay. In this figure, you can see the protocol for this process. A first set of assays carried out on samples from 10 independently selected women showed chemotaxis index values that they observe opposite chemotaxis index values from the same individual along a period of 1 month. This data suggested a major role of the female hormone cycle in modulating the chemotactic response of nematodes. To prove this, they collected biological samples 3 times a week from 6 healthy, fertile, pill-free women, 3 and 10 being 40 years. Sample collection started 2 days following the end of the menstrual cycle and finished at the beginning of the next. In this figure, you can see the positive correlations between the chemotactic response of animals and both the follicular and pre-ovulatory phases. While a peak in the estradiol release characterized the former phase, the levels of the follicular stimulating and luteinizing hormones promptly rise during the later. Similarly, a positive chemotactic index was measured during the mid-luteal phase, which is characterized by a second wave of estrogen release associated with the progesterone peak. The shape of the pre-ovulatory peaks was smaller within group 1 compared to group 2. In agreement with the well-established change in hormonal release with aging. These findings demonstrate how the avoidance behaviors of C. elegans stores control urine samples is strongly influenced by the menstrual cycle. For these reasons, it was important to take samples of 30 women few days after the end of the period between the follicular and luteal phases in order to avoid false positive results. Secondly, they did assays with 2 women groups, either with primary breast cancer and healthy ones. They proved different concentrations of urine samples and found that the maximum attraction to breast cancer samples, as well as the highest avoidance towards control, peaked at the dilution of 10 to the minus 1. The population's assays showed the C. elegans displays a significant preference for samples collected from women with breast cancer, you can see in this figure, whereas control urines behave as chemorepellents promoting avoidance. The sensitivity of this test was 55%. And the specificity it was 97%. Okay. The nematodes have three main pairs of olfactory sensory neurons, and to facilitate this explication, I call neuron A, B, and C here. The neurons A and B mediate attraction to volatile odorants, while B neurons mainly respond to repulsive compounds. Besides, this neuron ASH is reported to be associated with aversive stimuli. To effectively determine whether C. elegans perceives cancer metabolites and with what accuracy, they use calcium imaging and transgenic worms expressing a calcium indicator on the neuron of interest. The olfactory neuron synapse onto several interneurons, which act on motor neurons that initiate movement towards or away from the source of the stimulus. The C neuron activity responds during the addition of cancer urine samples, while it is silent with healthy control samples. After they proved with a mutant strain in which both the C neurons were ablated, and this shows that these worms have reduced ability to sense cancer metabolites. Additionally, they determine the neuron activation index to compare with chemotactic index and measure the necessary concentrations to urine samples, and they found that it was 10 to the minus 2. Okay. This suggests that metabolites eliciting the activations of C neurons are less concentrated in control samples in comparison with samples from cancer patients. Now, for high throughput experiments in calcium imaging, they simultaneously record neuronal activity for multiple nematodes. These are loaded onto a custom microfluidic device with an all-liquid environment with a design based on the Pulse Arena chip. They acquire results for women with breast cancer and healthy subjects. This figure shows typical traces obtained for the sample of both groups. To calculate the neuronal activated index, they employ a custom script that extracts the fluorescence traces from the videos and evaluate them. This figure shows the process for an example images with the script. And here you can see a bar plot reporting for each sample the resulting of neuron activity index and the chemotaxis index. As expected, the cancer samples are associated with a positive index, while healthy subjects have a negative index, meaning that the first group elicits the activations of C neurons as opposed of the second one. Finally, to identify G protein coupled receptors involved in the attractions toward cancer samples, 5 mutant strains were tested. 2 of them result in a significant lower index compared to wild type, suggesting an involvement of these receptors in responding to breast cancer urine samples. Um, okay. In conclusion, the small nematode C. elegans hold the potential to help design a fast and cost-effective diagnostic screening test for breast cancer with high reliability based on the simple collection of biofluid. Okay, that is all. Thank you.
Anyone has any question? I have one. Maybe I couldn't follow you. Uh, they have a, development and an approach to understand which part of the nematodes have the ability to sense, but they didn't talk about what they are sensing, no? What element they see.
Um, I don't understand.
It's okay.
Um,
Uh, it's
I don't hear you very well. Sorry, it's my computer. But
no,
yes, tell me, tell me.
sorry, we have echo.
Yes,
They are talking about the mechanism of the nematodes to sense something in the women's urine, but they don't talking about what they are sensing. Only that this urine is different from the control because this person have cancer, breast cancer. No, it's
yes.
not. They don't say these animals are sensing this compound.
No, it's all the compounds of the sample,
Okay,
and they don't determine until now, until today, which is the compound.
that. Uh-huh.
Yeah.
And it's. I think I don't have any idea about your line of work, but it's very strange to think that they are be attractive for something that is it's an illness. No, what is the
Yes.
compound that they and why? Because it's not natural that they are going to be next to this kind of samples in the nature. No.
Yes. The nematodes are very sensible to. They can detect compounds in in, in nanomolar,
Okay.
uh, and are very, like I said, sensible of these compounds. In the paper,
Sometimes they
they
are
don't.
attract, and sometimes
They
not.
sorry.
They sometimes be attracted to that compounds, and sometimes they are going to be repulsed, and you use that ability.
Yes.
Okay.
Yes. Mm.
Okay. Thank you. Uh, well, if you don't have any question for Andrea, we can follow if you want, Eric, or then I can go.
Okay, Camila, here we go.
Okay.
Can you clearly see my screen?
Yes.
Thank you. Okay, today I'm going to talk about classification of mammogram for early detection of breast cancer using support vector machine classifier and host transform. In this paper, methods for classification and feature extraction are presented. Here, host transform is used to detect characteristics of a mammogram image and its classifier using support vector machine. Um, Regarding the purpose methodology, we can see here in figure 1 the block diagram. First of all, Preprocessing state is used to remove the label and background noise in the digital mammograms. After removing them, a host transform is done on region of interest to extract feature and justify them normal or abnormal using support vector machine classifier, as we will see below from figure 2.9. Here, figure 2 represents the unwanted region of breast cancer and tumor. The region in yellow is the breast region. Unwanted label background is represented using the blue circle and red circle, which represent as tumor. The unwanted label should be removed first by using gradient-based threshold methods, as we see here in figure 3, a binary mask generated through gradient. And figure 4 shows the label remove image. At the same time, morphological operations were applying such dilation of film, which aims in the binary image is to bring maximum breast region and removing the pectoral image in the mammogram for efficient feature extraction using maximization methods, as we see here in figure 5. On the other hand, Kenny H detection is used in pre-processed image before applying the host transform, we see here in figure 7. In addition, it also presents an optimal age detection filter to isolate step H, as we see here in figure 8. Regarding feature extraction using host transform, host transform is a two-dimensional transform. It's used to isolate feature of particular shape in an image. The normal parameters is given by equation 3. The feature should select it carefully because sometimes may reduce the efficiency of the classifier. Regarding classification, after obtaining a feature from mammogram image, the values are given to the classifier according equation 9. Support vector machine gains the accuracy of 94%, which is higher when compared with all other classifiers. Furthermore, this classifier uses the values of trained image, and thus is really easily classifiable the test image. Finally, about results and discussion. In this work, intensity features are selected, such as mean, variance, entropy, and standard deviation for better results because of the difficulty in interpreting the shape of the tumors. Table 2 and Table 3 show the parameters obtained with and without detection using scanning methods. Table 4 and Table 5 show the result after applying the classifier for with and without age detection. The mentioned methods is applied to 95 mammogram image with normal and abnormal image. As a final conclusion, we can say by having support vector machine classifier, the accuracy range of 94% was obtained, which is higher when compared with another classifier, for example, linear discriminant analysis, which has only 86% of accuracy. From the results, it shows that the proposed methods is effectively classifying the normal classes of mammograms. That's all. Many thanks for your attention.
Sorry, I was without internet for a moment. I lost you. The number of the sample training samples on the the results samples are a little bit small, not? Or is it normal to use this kind of number? Yeah.
I'm sorry, can you repeat the question?
Sorry. The number of samples, the training samples and the test samples are a little bit small, or is normal to use the kind of samples?
Yeah, it's normal to use this sample. There are 322 mammogram images
Okay,
for this 95 image taking
I just
for
read
this work.
the 23, and I think was that number. Sorry.
Yeah, yeah,
Okay.
yeah. That's right.
Uh, well, it's very interesting. It's interesting this approach, no, that how they change this sensibility. I don't know if the term is so correct in this case, but improve it, no?
Yeah. Because you have a key two parts. The first one is the image processing, and then machine learning algorithms. And in this case, classifiers support virtual machine, and they improve
Hmm.
the efficacy of the meshes. Yeah, that's
Hmm.
interesting.
Okay, very well. Thank you. Well,
Thank you. Hopefully.
anybody has any question? Well, I'll go on. You can see my paper.
Yes.
Okay. Well, I select this paper to show you because we have a problem. It's about the possibility to encapsulate or include agarose bead inside the chambers of the microfluidic devices. And I was thinking some kind of new approach. In this case, this paper, they used frit-free PDMS microfluidic devices for chromatographic separation and on-a-chip detection. This paper has some difference about our approach. They use another kind of matrix. They use um, liquid chromatography um, matrix, and we are having affinity matrix. But well, the interesting thing is how to not let the bits go out the chip using something that is not in the interrupting the fluid uh, when it's enter and follow going out the chip. Well, they used PDMS microfluidic chromatography devices, and they used as a matrix the atomea earth that are similar to silica, that is the normal compound of the liquid chromatography columns, and they use it like phase normal phase stationary, and to not let the matrix to go out, they use magnetic nanoparticles. Um, well, this is what I just said. Um, uh, well, one thing that is very interesting that the atomea earth are less expensive than silica gel matrices, and they use it because they can push these nanoparticles, magnetic nanoparticles, that are smaller than the pore size of the atomeas. Here we have the size of the nanoparticles is between 40 and 65, and the pores are 300 to 400 nanometers in diameter. And the strange thing that they could to put these nanoparticles to go through this the atomic earth, but also to embed it inside the atomeas. They put this mixture inside the microchip. I have this scheme. They have two ports in the inside in an inlet. One is for to put the diatomeas and the nanoparticles, and the other is to put samples on buffers. The strange thing that they put together the atomea Earth and the nanoparticles, and to put a magnet down the microchip that make that they clunk the this tube, this pathway, and then they put only the atomeas with a higher flow, and all are empacked inside the chamber. In this case, the chamber is with ace shape. Uh, well, then they prove it using to separate dyes. This imagine is the axial cut using SEM images, and you can see the diatomeas impact in the tube. And in this imagine, you can see that the nanoparticles help to link the diatomer Earth to the PDMS channel. Well, here you see this is the nanoparticles with the diatomers, and they push the dyes and can separate the yellow to the blue greenish dye. Well, that is all. Do you have any question? You can hear me? Hello? No?
Yes, yes, I can
Sorry.
hear you.
Well, if you don't have any question, we don't have any more presentation, I think. This is all.
Thank you, Cami.
Well,
Okay,
bye-bye.
thank you.